Okay, so this is the sign magnitude adder with outputs being in binary on the LEDs and in hexadecimal on the 7-segment display. So the first 4 switches are dedicated to the inputs of A, and the next 4 switches are dedicated to the inputs of B, with the most significant bit being on the left and the least significant bit being on the right, for both of the numbers. And you'll see it works just fine as an adder. I'm only going to mess with the side of A, so and it counts up to 7, 3, 4, 5, 6, 7, and then we have sorry, that's 2, 1. And this is only messing with the side of B now. 1, 2, 3, 4, 5, 6, 7. Great. And then, oh, sorry, let me show you. We get 7. And if I turn on this one, we'll get our overflow, which you said in class we can ignore. And we're just supposed to implement your circuit from what I understood and from what other students understood. So I believe this is the case where, like, for example, if we had 1, 1, 1, and, okay, I won't flip anything. I'll just do it in my head really quick. So if we had 1, 1, 1, 0 and 1, 1, 1, 0, and we added them together, normally we would get 1, or 0, 1, 1, 1, with 0 being the least significant bit and 1 being the most significant bit, the third one. But instead, because of how we're doing our because of how we find use the magnitudes of A and magnitudes of B, and how we actually implement the sign bit. So because both these signs are 0, our sign bit is going to be 0. Because we literally have an if statement that compares the two signs, and it says if mag sum it says mag sum equals max and min. So what it's going to do is just going to add these two things together, and we would expect that to be E and 1, 1, 1, 0, like I said earlier. Sorry, I had to recalculate it because I forgot. But instead, what will happen is we should get 0, 1, 1, 0, because we cut off the most significant bit, as our magnitudes are only actually 3 bits. Yeah, and that's exactly what we get. And you'll see that the same is true. Let me do something on this side. Let's go to 9. Okay, that seems good. And then I'll subtract 1, and that'll give us 8, which is expected. However, and this is all expected. If I move to 2 on this position, you'll see that this becomes the higher magnitude. So 2, 1, negative. So it's going to be 2 minus 1 is going to equal 1. And the same will happen. The 3s. Yep. Exactly what we thought. Yeah. I'll just flip on something random so we know it's not just like wacky things happening, but like, okay, E. And then I'll turn on 3 on this side, and since that's a lower magnitude, we can expect that E will go down from E to D, C, B. It should go down to B. And that is exactly what we get. Cool. And then, yeah, I think that shows everything. We got a subtraction. I'll get like normal subtraction going on here, I guess. Where we have, and 3, 0, 1. Yeah, so sorry. What I did was I had -1 on this side, or -3 on this side, and I turned 3 on this side, and then I'll turn 4 on, and we get 1, 2. Cool. Yeah, everything works as expected. Yeah, hopefully this shows my understanding, and